friends, in this session we study about the application of derivatives. Derivative is the instantaneous rate of change of one quantity with respect to another quantity. We apply derivatives of a function as to find approximate values, velocity and acceleration of a body, determination of slope or tangents to the curve, determinants of maxima and minima of functions, and determination of increasing or decreasing functions. So here we see some applications. Here in motion in a straight line, we have to find out the velocity and the acceleration. So the velocity is defined as the rate of change of displacement, the change of position we could say also with respect to time. So velocity is equal to first differentiation of displacement equation ds over dt, as is the equation of displacement. And second thing, we had to find the acceleration. Acceleration is defined as the rate of change of velocity with respect to time. So we had to take the differentiation of velocity equation, so dv over dt, which is the second order derivative of displacement equation. We could write in this way, d square a over dt square. So here a is equal to d square a over dt square. So we differentiate the velocity equation, we get the acceleration. So now we look at one tutorial example for this. A particle traveling in a straight line moves a distance of s meter in t second, given by the equation s is equal to 3t plus t cube. We have to calculate here acceleration after 2 seconds, the time when the velocity is 51 meter per second, the distance moved in third second. So first we solve the acceleration after 2 seconds. So for getting this, first of all we have to find out the velocity. You know that velocity v is equal to ds over dt. We know this thing. So here, because s is equal to 3t plus t cube, differentiating both the sides with respect to t. Differentiating both the sides with respect to t. Okay, so we will differentiate it with respect to t. So we get, therefore ds over dt is equal to, we differentiate this function, 3 is the coefficient, we take it outside, d over dt of t plus d over dt of t cube. Therefore ds over dt is equal to 3. The differentiation of t is 1 and the differentiation of t cube is 3t square. So this is our velocity. Could write this is our velocity. Now we have to find out the acceleration, because we know that acceleration A is equal to rate of change in velocity dv over dt, or we could write in this way, d square s over dt square. So because v is equal to 3 plus 3t square. Now again differentiating both sides with respect to t. Therefore dv over dt is equal to ddt of 3, which is a constant, and 3 is the coefficient, so we take it outside. So dd over dt of t square implies that dv over dt is equal to, the differentiation of any constant number is 0, so the differentiation of 3 is 0, and 3. The differentiation of t square is 2t, and finally we get here dv over dt is equal to 3 into 2, 60. Now look at here in a part, what we had acceleration after 2 seconds. Now a part we find acceleration after 2 seconds, which is equal to 6 into 2, because instead of t we have to put 2, so we get here 12 meter per second square. So this is the acceleration after 2 seconds, 12 meter per second square. The second part we see what we have to find out, the time when the velocity is 51 meter per second. Time when the velocity is equal to 51 meter per second. So here I explain, because v is equal to, we have got the equation for v, which is 3 plus 3t square. And the velocity we required 51 meter per second. Instead of v, we have to put 51. 3 plus 3t square implies that 51 minus 3 is equal to 3t square. Implies that 48 is equal to 3t square. Implies that 48 over 3 is equal to t square. Implies that 3 1 times, 3 6 times, 16 is equal to t square. Therefore 4 is equal to t. So we have got here t time after 4 seconds, the velocity of the particle would be 51 meter per second. Now we see third one, distance moved in third second. Distance moved in third second is equal to distance moved in 3 seconds minus distance moved in 2 seconds. So here we get, because we know that the equation of distance is given to us 3t plus t cube. S is equal to 3t plus t cube. So here we have to write down 3t plus t cube. So we will take t 3 seconds first. So I write down here 3 into 3 plus 3 cube minus, in 2 seconds we have to take 3 into 2 plus 2 cube. Instead of t we have to put here in the first term we have to put 3 and the second term we have to put 2. So we get here finally 3 times 9 and 3 cube is 27 minus 3 2 times 6 and 2 power 3 is 8. we could write in this way. So we get here 36 minus 6 plus 8 is 14. 36 minus 14, which is 22 meter. So 22 meter distance has been covered in third second by the particle. So in this way we could easily find out the motion in a straight line, the problems related to the motions in straight lines. So thank you for this.